controls.
What happened?
Hide, there's an option to hide float meeting controls in the more.
What do you want me to hide here?
Hides float meeting controls right down there. Oh,
This one?
one row. That should do it. Yep.
And now what can I do then to go to the next one? And if I want to go now and stop, I mean, it doesn't matter. Then we're going to have to stop, but then you're going to have to let me know how I stop it, okay?
Yep.
Escape, okay. All right, so here we are. Now we need to do the same thing for the accelerations, okay? So let's say this was problem 1796. Continuation. Okay, so this time let's be careful because let's see, this time we're going to try to find, now we do the same procedure as before. We're going to find the acceleration of point B from point A. Okay, so if you need to look back at the equation, this would be equal to what? You should have one term due to the acceleration due to translation plus one term that will be the what? The tangential acceleration alpha cross S of what? If we start from B, okay, so what do we have? B bar A, B with respect to A now. This is the tangential. Then what are the other terms we are missing? Maybe I can zoom in. Looks a bit small from here. What is the other term we need? We need the term for the normal acceleration, right, which will be omega AB of S of what? B with respect to A again. All right, I don't know why I have a little square over there, but let's see if it will disappear if I click somewhere. It disappears, but everything else disappears. There you go. Now I hide it. Okay, so since point A is fixed, what is the acceleration of A? 0. Now, alpha cross SAB, remember that will be the tangential acceleration. Remember when we say about something is rotating, it will have one term which is tangential, one term which is normal, no? Yeah, or centripetal, okay? So anyway, we need to do the math. So what will be the cross product for this one? We'll have I, JK, 0, 0, alpha AB, I guess was given to the problem is equal to what? -6. Does -6 means that it goes counterclockwise or clockwise? Neither one. It means basically that it's slowing down, no? Right. It's for the omegas, no? Clockwise, counterclockwise. So be careful with that, okay? I mean, sometimes it will do it also on the figure, but here we go. So -6. Now, what is the position of B with respect to A? 2, 0, 0. Okay. So if you look at the figure, what should be the direction of the tangential term? It should just be going up, and the normal will just be pointing to point A, no? So let's see what the math are going to give us. Now, I guess before, now omega B is also given to us, which is equal to -4 squared. And now what do we need? Position of B with respect to A, which is what? 2, 0, 0. So if we do this calculation, let's do one term at a time. The first term is going to give us what? 0 and no, I think the y is the one that keeps the term. No, I mean, let me redo it. I'm just doing that one. It will be what? Negative will be 0,
0, 0, yeah.
Minus, and you have so the positive or negative.
Negative. J will be a minus anyway.
Correct. So it remains negative. Okay. So minus -12. You want 0. And then this one will give you what? I want to plus here the plus what? 16, 0, 0. But basically, you see, this term, which is a normal acceleration, only has the x component, no? As expected. And this will only have the y component as expected as a tangential, no? Yeah, remember?
Is it minus or plus?
16.
32. Forgot to multiply by 2, yeah, 32.
What happened to your negative sign?
You're correct, minus 32. I say I like to put it inside so I don't forget it, I don't forget it. So, but again, this is the normal, this is the tangential acceleration. This is the normal, no? Yeah, we look at the figure. So at the end, what do we have? We have AB is equal to negative 32, negative 12. If you want, you can put the 0 at the end or not. So now that we know AB, what can we do? We can calculate the acceleration of which point? We can go from point B to point C. Okay, so we can write AC will be equal to what? Let's see now if you start recalling basically the equation would be AB plus.
Why is the 32 on top and not the negative 12?
It's in the extra.
X.
Oh,
Why?
yeah.
Okay. So again, let's try to practice that one instead of just copying. What would be now would be the alpha of which bar? We go from point B to point C. B to C. So what is this bar? Okay, so it will be alpha BC cross S of what? C with respect to B. Remember, I told you the little trick to use the one outside to put it on top, no? Yeah. So this is the tangential minus omega of which bar? BC and S of C with respect to B. Okay, so now, do we know AB? We just calculated, no? Okay, what would be alpha BC? So we don't know alpha BC, that's one of the unknowns. What is the position of C with respect to B? Negative 1, negative 1, and 0. Minus, now we're gonna have to give me this stuff because I don't have the notes from the other day. What is omega BC that we calculated the other day?
8/3.
Okay, so 8/3 square. And this would be what? Negative 1, negative 1. So this is equal to negative 32, negative 12, plus what? What will be the X component? Will be positive, no?
Positive alpha, yes.
Positive alpha BC, and the second one will be negative alpha BC, and the last one, good luck. So this will be actually the both will become positive, so will be whatever. So what is 8/3 square?
64/9.
Okay, what is 64/9? Can you do a calculation so I can? I'm gonna need your help here, so or I can look at the solutions. Okay, 64/9 if you want. So I mean, I'm just trying. I mean, I can look at the solution, but I'd rather let's do it together. This will give you what then? Alpha BC minus what? Can you do this calculation? Yeah, so how much is minus 32 plus 64/9? I mean, I can look at the solutions, but how much?
Negative 24.889.
Okay. And please somebody double check because
That's correct.
okay. And the second one will be then plus 20, so it will be minus 44, I guess. No, the other way around. Should be
Let me see. Is the 12
12 plus
supposed to be
64
positive or negative?
yeah, so it's negative.
Oh, that's negative.
So should be this negative 12 difference. So
Negative 4.8.
yeah, so negative 4.889. Yes. Okay, last time, how do we call? Did we call this one 1 and 2 or A, B? It doesn't matter. I mean, I can change, but all right, then let's call this one letter A, okay? Okay, now that we have this, what is the strategy? Now the strategy is to find the acceleration of point C from where? From the other point that would be point D, okay? So from AC to point D. So we're gonna find acceleration of C equal to what? AD plus alpha of what?
C with respect to
Okay, CD doesn't matter, or DC or CD, no, it's the same bar. Cross what? S of what? C with respect to D minus omega of which bar? CD S of C with respect to D. What is the acceleration of point D? 0. So now we do again the algebra. That's why I told you that I have no doubt that you're gonna know how to do the cross product, okay? So this will be equal to what? 0, 0, alpha CD. What is the position of C with respect to D?
1, 2. Well,
No,
two,
what?
one.
Negative 2
Yeah, negative 2 plus 2.
and 1, no? And 0. This should be the same values that we had for the velocities, if you want to check with your previous note. That way. Then what was omega CD that we calculated last time?
Omega CD is negative 8/3.
Negative 8/3. Oh yeah, it's because we say it would be on the opposite sign, okay? Same sign. So square of negative 2 and 1. Okay, so this is gonna give us here negative alpha CD minus 2 alpha CD plus, now I need to be careful with the signs. So the first one will be positive, so will be what? 128 over 9, no? And the second one will be minus 64 over 9. So again, if somebody can do the calculations for me, this will give you AC will be equal to what? Minus alpha CD plus a value minus 2 alpha CD plus minus a value. Can you provide me with these two values, please?
128 over 9 is 14.2. Okay.
14.2, okay.
Then
Be careful, remember on the middle step, try to take more decimals, no? If it's not 14.2 exactly, okay?
Right.
For the assignment. But for this is fine for the procedure.
64 over 9 is, well, negative 64 over 9 is negative 7.111.
Yeah, it should be half of this. So 7.1 if we do that, no? So I'm guessing this is 14.21 or something like that, or 0.22. If this is 1.1, this should be 2.2, no? Okay, so whatever you want, okay? But no. And this would be our equation B. Okay, now what should be the last step? We're going to equate the two to each other because they represent the acceleration of the same point. So last step, equate A and B. So what do we get if we do that? we're gonna get alpha BC minus 24.889 equal to minus alpha CD plus 14.22 minus alpha BC minus 4.889 equal to minus 2 alpha CD minus 7.11. Now you have two equations, two unknowns. So last time I think we solved this way and you were okay with it. So but you can solve this any way you want. What could be a fast way to solve this? If we add these two together, what are we going to get?
You're gonna get,
So the alpha BC will cancel out.
so -3 CD.
So how much is 24.889 plus 4.889 minus 29?
But negative 29.778.
8 will be equal to minus 2 alpha CD minus 7.11.
Isn't that -3 alpha CD?
Is it minus 3?
-1 and -2, right?
Would be minus CD.
Negative 1, negative 2 over here, no?
Yeah. So,
This is for the X component, this is for the Y component.
right.
Ah, okay, add them together, yeah, so minus 3, you're correct. Minus 3, and this should be plus 7.11. I forgot about this. So now from here, you can solve for alpha CD. Maybe you can give me that directly. So you do, so it would be positive, I'm guessing. Yeah, it's going to be alpha. So
It
it's
is
6, between 6 and 7.
12 point,
12.
wait, what?
Yeah, 12 is possible. Yeah,
12
36 divided by 3. Yeah,
Yeah, 12.296.
12.296. Okay. Okay, and now what can we do? And let's say, and we can say that, and from either equation, okay, you want to put it here from either equation. Let's say we select the first one, we have alpha DC minus 29.889 equal to minus alpha CD plus 14.22. From here, we can find alpha BC. Just give me the value. Can somebody double check? And so let's see, it will be, so that should be about half. So we should have about, no, this should be 38 minus 1224. How much you find? 20 something?
Negative 26.813.
Yeah. Can somebody check? 26.93?
I missed the sign, it's positive.
It's positive? Okay.
Yeah,
So positive 26 point.
26.813.
Somebody else gets the same thing? Yeah, okay. So, any question? All right, so let's do another problem, okay? Why is this breaking all down? All right, so let's pick another one. Let's see, since we have the book here. Let's do this one here. Okay, 17, let me see. Yeah, let's do 1798, okay? So this time I'm going to copy the figure. I will do it from scratch. So go ahead and copy the problem statement. So 17.98. We have 2 bars. AB BC, which is connected to a slider. All right. Then what do we know? Omega AB, this is equal to 6 radians per second. If the acceleration of the slider C is 0, so let's say AC equal to 0 at the instant shown, what is the angular acceleration alpha AB? All right, and I put all those dimensions, which is whatever, from A to B is 4, from A to C is 3, from A to B is 4, and from B to C is 10. Okay, inches. The angular velocity omega b is 6 radians per second. If the acceleration of the slider C is 0 at the instant shown, what is the angular acceleration? Alpha AB. Okay, so we need to find alpha AB. All right. So if you look at what I've done, you can copy this figure, which is probably much nicer than mine. Are you done copying the figure? All right, so I go to my page, which is basically this one here. Same information, no? Basically. Okay, so okay, can we calculate the velocity of B from point A? Do we know everything?
We should not. Well, we don't know the acceleration that.
But we're finding velocities.
Right.
So let's first do one thing at a time. So let's say we first do velocity of B from point A. Can we do that? dA plus omega AB. And remember, for the velocity, we have one. Remember, motion, we can always break motion into translation and rotation. Yes? So VA is the translational, the rotational will be equal to what? Omega cross of what?
As B with respect to A.
Correct, B with respect to A. Since A is spin, what would be the velocity of A? 0. So again, we need to do another cross product. So I told you by now, I'm sure the cross product are getting easier, no? Okay, what is omega AB?
0.006.
0.006, okay. And what is the position of B with respect to A? 4. Perfect. 4, 4, and 0.
Is it negative?
Position of B with respect to A. No, everything is positive. Position of B with respect to A. So positive, positive, no? Okay. So this should give us what? VB. And if you think about it, what should be the direction of the velocity? Tangential to this one, no? Yeah. So we should have two components. So this should give us what? What should be the X? Negative 24, and the Y. Does that make sense or no? It would be pointing back, no? Since the X is going back and the Y is going up, it would be pointing in a direction, no? So no idea about the magnitude, but at least the direction makes sense, no? From the figure. Okay, so now We always try to find the velocity of one point from two different locations now. So there is not 3 points, but what do we know about the velocity of C?
C, it only moves on X.
Correct.
On the
So
x-axis.
because it's a slider, this is forced to only move on the X, no? Yes. So if you look at here, we could say VC will be equal to what? VCX and 0. Do you understand this? It's because it's forced to just move on the X, no? Yeah. Okay. So that's it. We're gonna say. So now, if we calculate the velocity of point B from point C, we can write down what? VC plus what? Omega of the bar BC cross S of what? Remember the one is outside come first, no? B with respect to C. Now here, be careful. What is VC? It's only one component on the X plus I JK of B with respect to C. What is the position of B with respect to C? So sorry, we have 0, 0, omega BC. I forgot that one. Now, what is the position of B with respect to C? Negative 10 on the X and positive 7 on the Y and 0. So again, we do the same thing as before. VB will be equal to VCX 0 plus minus 7 omega BC. And the other one will be minus 10 omega BC. So this will give you a second expression for VB to be equal to VCX minus 7 omega BC and minus 10 omega BC. Okay, so let's call this expression letter 1, letter Roman 1, letter Roman 2. Basically, we follow the same procedure, no? We start from one point that we know everything, and if we can do that, we do it. Otherwise, we go and equate the velocity of one point from two different locations. Okay, so the procedure is working again. Okay, last step will be to do what? Equate one to the other. Okay. So equate one and two will give us what? So we get minus 24 equal to VCX minus 7 omega BC, which that one is not going to help us much at this time, and 24 equal to what? Minus 10 omega BC. Okay, can we solve directly for omega BC from the second equation?
Yeah.
So we're going to get from here, omega BC will be equal to negative 2.4 radians per second. Here we don't need it, but if you want, you can calculate what would be the velocity of C, no, of the slider. Correct? I mean, if you want, let's do it. It's not needed, but if you want, let's do it since we're doing it. And then from here, you could solve VCX to be equal to what, even though it's not required. So 14, 14, so 16, whatever.
40.8.
14. I think it's about 10, so 9, 10. I know it's positive, so it's like 14 plus 24, like 36 something.
40.8.
40, okay.
7 times 2.4 plus 24.
Yeah, so you get 40.8. Okay.
Sorry, 40.
Yeah, 40.8. And this is, I think the units were inches, so I mean inches per second. But I mean, it's not needed for the problem, but this is what will be, no, if you needed to calculate it. Okay. You see, the bad thing is that once they ask you to find any acceleration, before finding the acceleration, you need to find the velocities, no? I mean, sometimes you can do directly to the accelerations, but in most cases, you need to go first to the velocities, okay? So now, if we want to find the acceleration of this bar here, first thing we need to do is what? Interesting here. They don't give us, okay, it's fine. I mean, we follow the procedure, okay? Let's see where it's going to take us. So next thing we can do is what? Find the acceleration of point B from where? Point A and point C, no? Okay. This time, what do we know about the acceleration of point C? Is 0, okay? So let's first find the acceleration of point B from point A. And let's see what happens, okay? So we get acceleration of A plus what? Alpha AB cross S of B with respect to A. Which term is this one? The tangential or the normal? This is a tangential. The next one, omega squared B will be the normal, no? This is important that you make the difference between each one of the terms. What is the acceleration of A? 0. So again, cross product. IJK. Do we know alpha AB?
No.
No. Okay, so let's just write it down and we figure out what happened next. Okay. What is the position of B with respect to A? You can use the one that we did before, but okay, 4, 4, 0. Now omega AB was given to us, no? Omega AB was given to us to be 6 square times 4 and 4. So that means that we're going to get acceleration of B equal to what?
4
minus 4AB. I mean, I don't even try to do it. Me, I kind of memorize this. The first one is going to change signs. The second one is not going to change signs. Okay, that's the way I do it. Hopefully, I'm not wrong. Okay. But you see, I don't even think about it to tell the truth. Is that first one would be
second term. So 0 minus 4 alpha AB. So yeah, it's negative.
so the first one changes the sign, the second one keeps the sign. Okay.
Yeah.
So minus 4 alpha AB, and this should be 4 alpha AB. Okay. The truth, I do it now without even thinking. Okay, yes, but I know it's correct. Okay. And the second one would be what? Plus, okay, what is 36 times 4? Would be 112, no,
144.
144. So minus 144. Yeah, it's 120 plus 24 minus 144. So we get this one will give us acceleration of B equal to minus 4 alpha AB minus 144, 4 alpha AB minus 144. And let's say this will be expression 3. Okay. Next, what can we do? We can calculate the acceleration of point B from where? From point C. So we know acceleration of B will be equal to acceleration of C plus what? Alpha of what?
Alpha BC.
BC, correct? Cross S of B with respect to C minus omega squared BC S of B with respect to C. See, I mean, that they tell you the acceleration of C is 0. What does it mean physically?
It's moving at constant speed.
It's moving at constant velocity. Either the velocity is 0 or it's moving at constant velocity, which is the case in this problem, no? Okay, so again, a cross product. I, JK, 0, 0, alpha BC. What is the position of B with respect to C? You can look at what we did before. Negative 10, 7, 0 minus
7,
omega BC. We found out to be equal to
7. Oh,
no, negative 2.4
Yeah.
square times minus 10, 7. So you're gonna have to help me over here, no? So let's see, this will give you acceleration of B equal to what? What should be the first term?
Now it's negative 7.
Negative 7 alpha BC. Second one keeps the sign. The second one keeps the sign minus 10 alpha BC. And what should be the next term? Plus, so the first one will be positive. So 2.4 square.
That is 5.76.
5.66. So this will be then
57.6.
57.6.
It was negative sign there, so wouldn't it be negative?
Oh,
But it's negative.
Ah, yeah.
And then the other one will be what? 2.4 times 7. So 5.76 times 7, whatever, 30 something, 30 high.
40.32.
Oh, so 40.32. Okay, so that means that the second expression
I think the first one, yeah.
is this one is negative, no?
Yeah, that's negative.
So the second extent would be negative 7 alpha BC plus 57.6 minus 10 alpha BC minus 40.32. And this should be equation 4. I mean, you see, I kind of did it almost without thinking, not just following the procedure. And hopefully it's going to work. Yeah, it's going to work, okay? What is the last step on the procedure? We equate. Equate 3 and 4. So you get minus 4 alpha AB minus 144 equal to minus 7 alpha BC plus 57.6. 4 alpha AB minus 144 equal to minus 10 alpha BC minus 40.32. Again, what do we have? Two equations with two unknowns. You can solve it any way you want, no? But if I do this, you're gonna have to help me anyway. So minus 288 will be equal to minus 17 alpha BC
Plus 17.28.
plus 17.28. So now you can just give me the result for alpha BC. We haven't been too smart because we should have canceled the other one, but it's fine.
Yes.
They don't ask you for alpha BC, but how much?
17.95.
17.958. Okay. Positive.
Yes.
Okay, radian second square. And let's say, from the first equation, doesn't matter, minus 4 alpha AB. You can use either one, okay? Equal to minus 7 alpha BC plus 57.6. You're gonna give me the result right away. Alpha B will be equal to what? I mean, the best way to practice in class for you to do a promise is to do the calculations with me. Okay, I mean, to do calculations. Yes. What is it?
Negative 18.97.
Somebody did the same thing.
Yeah.
18.97. Okay.
It's negative 18.7.
Yes.
So is angular acceleration always going to be radians a second or per second square?
Yes. It's like meters per second square for normal acceleration. For angular for rotation is radians per second square. Okay, so you see basically that this kind of work all the time, no? So we have 20 minutes. These ones are a bit more difficult. We haven't covered that yet, I guess. Okay, so do you have questions about the assignment? No? Okay, so let me pause this for a second then. I guess it's pause share or pause the recording. I don't know how I can do this. Okay, so about the assignment 30.84, what is your question?
I'm not sure how to equate the equation you've been using when I'm not sure how to put the slope since it's not a straight line, so I think.
Okay, I mean, let's look at it. No, once again, let me put the overhead projector, but let's look at the problem before I do the figures. I'm going to do the figure 13.84. I'm not going to do it, but I might just give you some hints, okay? So a projectile is launched at 10 meters per second. So you know the initial velocity. From a sloping surface, the angle is 80 degrees. Determine the range R. Is that all the problem? Okay. So I do the figure. A little bit different, but I do the figure. Okay, I know why they do this stuff then. And then we have here, let's say this should not. This sub naught at an angle of and what is R? Yeah, this can be a little bit tricky. I understand why you ask this. Okay. So this is a problem, no? Okay, so first thing you need to decide really is what is going to be your reference frame. No? So what's going to be your reference frame?
Tilted over 30 degrees.
Where are you going to start it?
I would start it along the slope that we're.
So
on-
let's discuss this stuff. So what are the options you have? So let's say we start, doesn't matter which one, let's say we're gonna start from here, okay? So what are the options you have? You can either do this one, like most of the time we do, or which one can you do? You can do the one that would be along the surface, okay? So the one which is good along the surface is that R would be the maximum range, no? Okay, and the second one is that that line, this becomes a new line, no? The one of the range. But which one do you think is better, these two coordinate systems? The one that is along the surface or the one that is the traditional one?
Along the surface.
Along the surface. I mean, you can use either one, okay? It's not that one is easier than the, I mean, one I think is easier than the other. Okay. So what is something when you derive the equation of motion? What is the only force acting on an object moving over here?
Gravity is the only force acting on the object.
Gravity, no? So gravity is oriented in what direction? Correct? So if you use the first one, gravity is only going to have one component. If you use the second one, gravity is going to have two components. Yes? So you can do it in either way, no? And you can follow the procedure of A equal to what? If you do now, you derive the equation of motion, you can derive what? A, here you can say will be equal to what? One component or two components, no? All right, so I'll let you choose. Which way will I do it? To tell the truth, I will use this one. Okay? Why? I mean, you don't have to do that way, okay? But if you do it this way, basically, you know, this is this. X, Y, no? And you can derive this the normal way, no? Which would be what? 0, negative G. I'm not going to do all the details. Now, what would be V? V would be equal to what? V naught X would be whatever is the sine over sine, no? And this would be minus GT plus V naught Y, no? And then you will have here S equal XY will be equal to what? Sometime V naught XT minus GT squared over 2 plus V naught Y squared T, no? All right. Now you can transform, you can eliminate the variable T to write this in function of X. Okay. And what would be the V naught sub X? Would be V naught sine cosine, but what would be the angle? Is not alpha, no? Use this one, what would you have? Probably alpha minus theta, I'm guessing, no? Yeah, does that make sense? Okay, if you use this one, now you know the equation of this curve. So from this, you can get the equation for y of x, no? Yeah. Now, can you find the equation of this curve over here? Let's call this one g of x, okay? What would be the equation of that curve? What would it be? I mean, is of the form what? Y equal or J equal is of the form AX plus B, no? So this is 0. What is the slope that is going down? So it would be, if you want G of X would be negative what? I mean, whatever you want is the slope of this line, no? Yeah. I mean, I don't want to do all the work for you. Minus slope times X, no? So maximum range will correspond to what? When the equation y of x and g of x do what?
They intersect.
They intersect. So in order to find the intersection, what do you need to do? You equate one to each other, no? That's the way I will do it, okay? But you can do it the other way around as well, but then you end up with two components for gravity, no? So again, I'm not doing the problem, I'm just giving you highlights of the way I would do it. Any question about what we just discussed? Yes. I mean, basically what I'm saying is that if you look here, I'm not sometimes, but if you look at this, okay, if I do the figure here of the projectile, this is X, this is Y, this is V naught, no? So the question is that what is beta here? You agree that beta is not alpha, no? Yes? Okay, so it's going to be related to this angle and this angle, no? Yes? Okay. I don't know if it's plus, minus, I don't want to do it, okay? But what I want to say is that don't say that is alpha. That's what I'm trying to say. It's a different angle. This one would be this is beta, okay? It's not alpha, it's not this alpha or that angle of or this angle over here. It's a different angle. Does that answer your question? More questions? Think somebody else had a question? That's it? Okay, that's fine. I mean, wait, we're not done. They have 10 minutes, no? So now we're gonna start. I'm gonna explain this, but I'm gonna stop the video because I'm gonna redo that next time.